We're solving problem 11 from the fall AMC 12A from 2021. Consider two concentric circles of radius 17 and 19. The larger circle has a chord, half of it which lies in the smaller circle. What is the length of the chord in the larger circle? So let's first draw these two circles. Say this is the one with 17 radius. Say this is the one with 19 radius. Now there's going to be a chord where, say at here is the chord, and we know that this length is 2 times the length of this. So that's something we know. On the side part is 2 times the length of the smaller one of the individual smaller parts. So say let's this point be the center of both circles, as they're in the same center. That's what it means to be concentric. We can start setting variables. Let's let this one be x, therefore this one's x, so this has to be 2x. If we draw all lines connecting from these points of intersections of the chords, we get something like this. And when we get a vertical bisector, we get a odd looking shape like this. And you note that the distance from the middle of the circle to one of these outer points is 19, as it's the radius of the outer circle, and this is 17 because that's the radius of the smaller circle. We know that this is a right angle, that is a straight circle, and a perpendicular bisector in this case is always perpendicular to that line. So we can use Pythagorean's theorem. So this might be a bit more accurate here. Where this is the height, we call that h as a variable. Well, 2x, see here that this is a smaller triangle. When you break that in half as you're taking one of the portions, you want to split it a big side down with this big triangle. 2x over 2 is simply just x. Try to make it more even. So x and x, and then this becomes 19, and then this becomes 17. So, well, now what we can do is just use Pythagorean's theorem. This should be a right angle. So h squared plus x squared is 17 squared, or 189. And when you do it for the larger triangle, you get the h squared plus x squared. That's 4x squared is equal to 19 squared, or 361. And, well, you have two equations, and they both have an h squared variable. And what we can do, the most logical thing, is just subtract these two. We subtract the smaller one from the bigger one. So this is just this bottom equation, and then you subtract the top equation from it. So these h squareds cancel. All you get is a 3x squared is equal to 361 minus 189, or simply 72. So that means x squared is equal to 24. The square root of 24 is simply 2 root 6. And so we have that. Now asks for the whole length of the chord, which is 4x. So 4x is equal to 8 root 6. So that is our answer for this problem.